Hello students, this is Miss Dalton and this is video 9.1, Rational Parent Function. Okay, a rational function is defined as the quotient of polynomials in which the denominator has a degree of at least 1. In other words, there must be a variable in the denominator. In simplest form, a rational function is going to be a fraction and you're going to have a variable in the denominator. The general form of a rational function is p of x over q of x, where p of x and q of x are polynomials and q of x cannot equal 0. Some examples are y equals 3 over x, y equals x minus 2 over x plus 1, and y equals 4x squared over x plus 5. Notice that they are all fractions and they all have a variable in the denominator. The parent rational function is f of x equals 1 over x. And so any variation of the rational function is going to vary off of this parent function. The graph looks like this here. What I want you to recognize is that it has what we call asymptotes here and here. So it has two asymptotes, a vertical and a horizontal. Remember, asymptotes are just a line that the graph approaches. It may or may not cross it. Most of the ones that we look at in Algebra 2, it'll just approach it and not cross it, but just know that as you go to a higher order math, you will see some examples. Okay, the domain of the rational parent function is going to look like this. It's just negative infinity up to 0, union 0 to infinity. Some people also write it as just x cannot equal 0. But in my course, we're going to write it like this. Okay, the range looks the same way. Negative infinity up to 0, union 0 to infinity. And again, some people will write that as y cannot equal 0. But again, this is what I prefer. There are asymptotes, like I mentioned before, at y equals 0 and x equals 0. So remember, when you write the asymptotes, you have to write it as an equation of a line. If we graph y equals 0, that's going to be the horizontal line here. And if we graph x equals 0, that's going to be the vertical line here. Again, you can't just say 0 because it has to be written as an equation of a line. So that it has to look like this. As with all the other functions that we've discussed in Algebra 2, rational functions, you can have transformations, and the equation will cause the transformation in the graph of the parent function. As the graph is shifted horizontally and or vertically, the asymptotes are affected as well. So keep that in mind, that if you shift it horizontal or vertical, it's going to move the asymptotes. So here's what I mean by that. If you have 1 over x plus 3 here, okay, we know that when that plus 3 gets added onto the end, that's going to move it up 3. Well, that's going to move the horizontal asymptote up 3 as well, making it y equals 3 instead of y equals 0. The horizontal transformations are going to be with the x. So if I have a plus 3 that is added onto the x, that is going to make it move to the left 3, and therefore it's going to shift the vertical asymptotes to the left as well, making it x equals 3. Okay, so that is it for this video. I just wanted to give you some basic information about rational functions. We'll do more practice of this in class, so please make sure you write down any questions that you have so I can address it.